Okay, so let's take a look at how to get StatCrunch to calculate a two proportion test and a two proportion confidence interval for us. Both of these are in the same place, and it's not that hard to do. We go to Stat and Proportion Stats, and now we're in the two sample proportion stats. And we don't have raw data, we have a summary of the data. So we've already been told the total in our sample and the total number of successes in the sample. So that's a summary of what would be raw data. In sample 1, we had 449 successes out of 483. And sample 2 was 286 graduates out of 295 possible graduates. We're testing the assumption that there's no difference, so we have P1 minus P2 equals 0 here, versus, in this case, P1 minus P2 is not equal to 0, so that test alternative is already selected for us. So if I hit compute, then what we see is a sort of a summary of what we're doing, a difference in the proportions, and our two samples, the counts and totals. The sample difference, which we had rounded to minus 0.04, that's extremely close. And then the z statistic, we had gotten, because of our rounding, minus 2.37, and because of rounding, our p-value was a 0.018 instead of a 0.0182. But we've done everything that we did on the board in half a second, and then we would just have to interpret the p-value, which again is the probability of getting a sample proportion difference like the one we did, or something more extreme, if there was really no difference in the true population proportions. And because that p-value is fairly small, just a 1.8% chance of that happening, and in particular because it's less than what was given for alpha at 0.05, this p-value indicates statistically significant evidence in our samples for a difference in the true proportions. So we would reject the null in favor of concluding that there is a difference in the graduation rates, and that the private school has a higher graduation rate. Okay, so I'm going to go back to options now and edit, just because I'm going to redo this, only this time, instead of a hypothesis test, I'm doing a confidence interval for example 2. The confidence level is by default set to 95%, which was what we were doing in that example. And I've entered all the sample data, so I just have to compute it. And we get the summary of what we entered for our data. Sample difference minus 0.04, the standard error, that's the 0.015, the square root portion of the interval. And then the lower limit, if you round, you get minus 0.07 and a minus 0.01, right? So that matches the confidence interval we did by hand with a calculator. All right, so when possible, I certainly would recommend using StatCrunch to calculate the intervals. Or to check them if you have to do them by hand in the homework or worksheet. But it's certainly not that much trouble to do. All right, that is going to do it.